Okay, so greetings. Welcome to Eureka Math Squared. This is grade 6, module 5, lesson 1. And we're hanging out on page 15. And today it's all about area of parallelograms. As you can see, we have a parallelogram here. And I suppose the first question they're asking is, let's see, what really is the height of this particular parallelogram? Well, they give us 3 units of measure. Now, let me give you a little bit of information about parallelograms. When finding the area of a parallelogram, now, a parallelogram is basically a four-sided, right, figure that has opposite sides that are parallel, right? So opposite sides, those guys are parallel. Opposite sides, those guys are parallel. And also the opposite sides have the same length, right? So this guy has the same length as this guy. This guy has the same length as this guy. Basically, that is the definition of a parallelogram. It has nothing to do with angles, just opposite sides parallel, right? And opposite sides are equal in length. Okay, so once we have that basis down here, what we're looking for here is the area. What is the space inside? Now, area is always measured in squares, right? In other words, how many squares fit in this shape if we were to fill it in or fill it up with squares that are all exactly the same size? As you can see, this is not as easy as a rectangle or a square because it is slanted, right? So if we were filling up a square with squares, life isn't so bad, right? You can fit all those buggers in there nice and neat, right? Rectangle, similar, right? So you can fill up your little squares, put them all in there, count up the squares, and you have your area. Parallelogram, not so much, okay? However, here's the trick with a parallelogram. All parallelograms are really just rectangles that have been tilted off to the side a little bit. Here's what I mean by that. Do you see this right angle right here? Okay, and you have this dotted line cruising on up here. But what if I took this little triangle right here and I cut it off and I put it right over there? Maybe I flipped it a little bit, right? It would fit perfectly right there. So if I took that guy, put it on over here, right, and I flipped him over, he would fit right there. Now what I would have is now a rectangle. See, there's my rectangle right here. Here's my wonderful rectangle. Okay, now here's the deal. As long as I can find the area of this wonderful rectangle that I just created, guess what? I also found the area of the parallelogram because it's exactly the same size. I took this guy off and I put him over there. And so as long as I can find the area of the two parts together, then I'm good to go. Okay, so now that you look at it, you say to yourself, hey, what are the two most important dimensions for me finding that area? Well, if it was a rectangle, right, you have your length and your width. But this is not quite a rectangle, right? We have this guy, right? So that would be 10 centimeters, right? And the other guy would be the 3 3/4. Guess what is left out? That 4 centimeters. Who cares? He's a diagonal. It means nothing to me. It's really about this 3 3/4 because that's what the 3 3/4 would be on the rectangle. And it's about this 10 because that's what would be the most important for the rectangle itself to find the area. And that's how it works. So instead of using a length times a width for the area of a rectangle, an actual rectangle, for the parallelogram, we just call it a base and a height. So it's just a base times a height. This guy would be my base. This guy would be my height. Notice that they do form right angles, and that's the trick of it, okay? Only use two values that form right angles. That leaves this guy out for sure. He's done. So who was right? Well, I think Kayla's right because Kayla's saying that the height is 3 3/4 because that is what forms the right angle with the base. The 4 centimeter does not form a right angle with the base. So Kayla is right. Kayla is correct. The 10 centimeter and the 3 3/4 centimeter form a right angle. That's it. Okay, it's all about that right angle. All right. So now you can put this into practice. You see this right angle over here, right? They want the area, they want the base and the height. And I could take this guy here and I can cut him off and I can put him over there, which means it's 9 centimeters, excuse me, 9 millimeters. Doesn't matter at all. So here is my base or my height. And this guy is my base or my height, right? Height, right? And that's how it works. So base could be either the 20. You can switch them around. It doesn't matter. If you want this guy to be the base and this guy to be the height, that's fine. Or you want him to be the base and this guy to be the height. It really doesn't matter. So the point is you can't use that 9 millimeters. There and a 20 millimeter there. And we're good to go. Same thing over here. We have the, let's see, if I cut this guy off, right, and I put him on over there, there's my rectangle. Notice I have my 9 centimeter as my base, and I'm using my 4, notice the right angle, as my height. What is left out? The 5 centimeter. Okay, so I'll put my 4 centimeter there. I'll put my 9 centimeter there. And if I was asked to find the actual area, I would take my base times my height. So my area equals my base, which is that 9 centimeters. And I would multiply it against that 4 centimeter. And my area would be 36 centimeters squared. Notice I'm using square because it's still squares for measuring area, right? So 1, 2, 3, 4, and then it would be 9 across, right? 2, 3, 4, 5, 6, 7, 8, 9 across kind of thing. Fill them all up, and you get your 36 squares measured in centimeters. Okay, so that's the deal, folks. That's how you find area of a parallelogram and how you know what units to use. Thanks so much. Have a great one. Take care. Bye-bye.